Good morning, students.
Good morning, ma'am.
Good morning, ma'am.
Good morning, ma'am.
You're able to see my whiteboard?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So last class we were talking about concurrency control using timestamp. So we saw what is timestamp ordering, what is timestamp ordering algorithms. The three different algorithms we were seeing. One is a basic timestamp ordering algorithm. Then we saw about strict timestamp ordering, and then we saw Thomas Wright rule. This is where I think, and then we went into multi-version concurrency control techniques. We also saw what is a compatibility table, how it can be done using log compatibility table. We discussed on that. I think that's where we stopped. Today, let us move on to what is validation or optimistic concurrency control techniques. So this is what we are going to discuss for the day. What is validation, optimistic and concurrency control techniques? We can call it as validation or you can call it as optimistic. No, in all the concurrency control techniques that we have discussed so far, that means we have discussed concurrency control using logs. That was the first technique that we discussed. Then we have discussed concurrency control using timestamp. These are the two techniques, and we have also discussed multi-version concurrency control technique. These are the three techniques that we have discussed so far regarding concurrency control. What did we observe is, in all these concurrency control techniques, certain checking is done. Okay, there is some kind of a checking which is done before the operation, or let us say before the database operation is executed. Yeah, there is some kind of a checking done before a database operation is can be executed. For example, I said we have seen locking. In locking, what did we do? We have done a check to determine whether the item is locked or not. Already whether it is locked or not. For example, suppose there is a operation read item of X to be performed by transaction T1. Suppose this T1 wants to perform this particular operation. What is the check that is done? First, you are going to check whether this X, that is your database item, whether it is already locked or not. This is the check that you are doing. If it is locked already, or let us say if it is already right locked, let's assume. If it's already right locked, then this T1 cannot perform any read operation on X. If it is read locked, it can still perform a read operation because reading is always a shared lock. Okay, so this is the kind of check that we are doing when we want to perform any particular operation using logs. Whereas in case of this is with respect to logs. In case of timestamp, what kind of check are we doing? The transaction timestamp, you are going to check the timestamp of the transaction. You remember something like this? We have defined what is a timestamp. A timestamp of a transaction is always given as TS of T1. Now you have to check whether this particular, you have to check this timestamp against the read timestamp of read TS of X. You should also check it with the write TS of X. This we have seen. Whenever a transaction issues a particular operation on a particular data item, you are going to check the timestamp of that transaction is checked with RTS or read TS of X, or and you are also going to check it with write TS of X. If this is going to be greater than your timestamp of that particular transaction, then you are going to abort it, right? And so on. We have so many algorithms. We have seen it in the last class. That means what I'm trying to say, these are the nothing but that kind of checks that you are doing on the transactions, on the whenever you are using any concurrency control. Let me summarize what I told. I said, whenever we have, so far whatever concurrency control techniques that we have seen concurrency control using locks, we have seen concurrency control using timestamp. In both these cases, we do some kind of checks, or we do some kind of checking before that particular operation is executed. In case of locks, what are the check that we are doing? Suppose a transaction T1 wants to do a read operation on the data item X. What is a check that you do? You are going to check whether this particular data item X is locked or not. Is it write locked? If it is already write locked by another transaction, then you cannot read that particular. That means transaction T1 cannot read that particular item. That is a check you are doing with respect to concurrency control using locks. If you are using concurrency control using timestamps, then what is the kind of checking that you have to do? If a particular transaction, again, same T1 wants to do a read operation with on X. So that particular transaction T1 will always have a timestamp. You have to check whether this timestamp T1 is less than read timestamp of X and write timestamp of X. You are trying to compare the timestamps. That is a kind of check that you are doing, right? Now, what does this checking represent? Now, these kind of checking leads to some kind of overhead during the transaction execution. Overhead means what? Some kind of extra time. It is going to involve, this checking is involving some extra time. So what will happen? It will slow down your execution of the transaction. It will slow down the execution of the transaction, or in other words, the transaction completion of your execution of the transaction is going to take more time. That is your drawback of this particular kind of checking that we have to do every time that we want to execute some particular operation. It involves some kind of a overhead, right? So this is the background under which we are going to learn about validation of the optimistic concurrency control technique. Any questions till here? Any doubts, any questions, any queries?
No, no.
Okay. All right. Right. So now let us move on to what is optimistic concurrency control technique. Now, this optimistic concurrency control technique is also known as validation technique, or it's also known as certification technique. Certification technique. Okay, in this optimistic concurrency control technique or validation or concurrency control technique, no checking is done. No checking is done while the transaction is executing. While the transaction is doing some execution, you are not going to perform any checks. Okay, there are several concurrency methods use the this kind of a validation technique. We will be describing one such scheme. There are many methods wherein you are not going to do any kind of checking when the transaction is executing. But there are several techniques, but let's try to talk about one particular technique. Okay, so in one of this particular scheme, what happens? The updates are not applied to the data item directly. That means, suppose you do a write operation. The T1 transaction T1 does a write operation on X. Okay, you are not going to update this X, or you are not going to write this X directly. Okay, you are not going to update. Yeah, you are not going to update this X directly. That means during the transaction, when the transaction is under execution, you are not going to directly update this, means until the transaction commits, you will not directly update X. Then what are we doing? During the execution of the transaction, all the updates, that means whatever changes you are making to that particular X, all that will be done on some kind of a local copies of the data item. That means there is a local copy of that particular data item which are kept for the transaction. At the end of the transaction execution, a validation, you will have a validation phase during which, okay, you are going to check if the transaction is violating some serializability. Violating serializability means what? Suppose you are you violating any kind of timestamp? Are you violating any kind of this kind of checks? All the checks will be checked during the validation phase. If nothing is violated, okay, then the transaction is committed and the database is updated from the local copy. You are going to update the final copy of X. If there is going to be some kind of a violation, that means the time this condition was not satisfied, you are trying to check some conditions. No? If these conditions are all checked during the validation phase, not during the execution of the transaction. So if they have violated it, then you will have to abort the transaction and restart it once again. That is what happens in this case of optimistic concurrency control. There are basically three phases under this optimistic concurrency control. The first phase is called as the read phase. Right? Second phase is called as the validation phase. The third phase, call it as the write phase. These are the three phases that come under this optimistic concurrency control technique. What does each one of them do? During the read phase, the transaction will simply read the values of the data items, but updates are updated. If you are going to update something, of course, there will be no update when you are doing in the read phase, okay? It will read. It has to read and then only it has to write anyways. So the transaction will read the values of the data item from the database. And then if there are any updations, it will apply these updations to the local copies or versions, local versions of the data item, which are kept in, where is this local copy? They are all kept in some temporary workspace or a transaction workspace. You are going to update it, something like a cache memory, you first update it in the cache memory and then you are going to the disk and updating it, right? It is something like that. So updates are applied only to this local copies which are placed in the transaction workspace. That is what it happens in the read. It will read the value of the committed, already finally updated data items are already there. So first it wants to read that particular value X. It will read it. And if it wants to change the value of that X, it is going to write it in the local copy. It will not write it in the final copy of X. Then the next phase is validation phase. What happens here? Here in this phase, the checking is performed. Now the checking is performed, not during the execution of the transaction. While the transaction is getting executed, no check will be performed. Now the transaction is over. It has already read and it is updated in the local copy. After the updation in the local copy is over, the checking is done. So what do you check? You are checking just to see that nothing is violated. The transaction has not violated any of the rules. You want to check the timestamp, or if you have used lock lock principle. You want to check whether write lock, shared lock, all these things you are trying to check. In the write phase, what will happen? If this phase, if the validation phase has been successful, then the updates are applied to the database. That means from the local copy, you are going to update the database. Otherwise means if this validation phase is not successful, that means the transaction has violated something. In that case, the updates will be discarded. Whatever updates you have done will all be discarded, and you have to restart the transaction. You have to abort and restart the transaction. Okay, so there are three phases here: read phase, validation phase, and the write phase. In the read phase, the transaction will read. Suppose it wants to write X, it wants to update X T1. First read phase, what will happen? It will first read the value of X. What is the value of X? Let us say X is 10. It will read that value. Okay, and then it will update it because the transaction is getting completed here itself. So when it updates, what it will do? It will update the local copy. So in the local copy, it is going to update it as 5. It is not updated in the database. It is updated in the temporary workspace of the transaction. Every transaction will have a workspace. In that workspace, this X will get updated as 5. So transaction is completed. It is over now here. It has done, it has executed all the steps. Next comes your validation phase. In the validation phase, what will happen? It is going to check whether this transaction has violated something, violated any rules. If nothing is violated, that means the transaction has, that means the validation phase is successful. So in that case, it will come to the write phase. In the write phase, what will happen? This X is equal to 5 will get written in the database copy. If there are no violations by the transaction. But if the transaction has violated something, then in this write phase, what will happen? Whatever changes it has made, X is equal to 5, it has made that change, no? That will be updated. That update will be discarded. So transaction will be aborted and you have to restart the transaction. Okay, so the idea behind this kind of optimistic concurrency control is you do the checks all at once. All the checks are done together, all at once. So in this case, what will happen? A transaction execution, the amount of overhead will definitely be minimum. If there is some kind of interference among the transaction, that interference means what? Overlapping of transactions. If it is there, then if there is only little of interference, then the validation phase will be successful. But if there is too much of overlapping, too much of interference, then many transactions that execute to completion will have to be discarded. You will have to discard them, you will have to abort it, you will have to restart once again. Okay, any questions?
Ma'am, can you
Yeah.
explain the optimistic concurrency technique once again, ma'am?
That is what I have explained till now. Any doubts in that?
Ma'am, I don't get that, ma'am. So,
See, in case of optimistic concurrency control, so far, whatever concurrency control we have learned concurrency control using locking, we have learned concurrency control using timestamp, and so on. In all these cases, there is some checking that is done before the database operation is executed. That means if you are using a lock, then you are checking whether if you want to do this particular operation, read item of X, then first we have to check whether X is write locked or read locked, or is it unlocked. So first you have to do that kind of a check. If you are using timestamp, then you have to check whether timestamp of the transaction is it less than read timestamp of X, write timestamp of X. These are all we have seen in the last class. This kind of checking you have to do. Whereas when you do this checking, what will happen? It is going to lead you to a lot of overhead. Overhead means what? There is a lot of time consumption. Because you are doing this activity, your execution of the transaction will slow down. So in case of optimistic concurrency control technique, we will not be doing, there is no checking done when the transaction is under execution. So you allow the transaction to be completely executed, allow the transaction to execute. After the transaction is executed only, you will try to check or you try to do a validation. So that's why we say there are 3 steps or 3 phases in concurrency control, optimistic concurrency control. What are the 3 phases? The first phase is a read phase. In the read phase, it will read the value of X and do the updations also. But the updations are done in some local copies. Local copy means what? There is something called as a temporary workspace for every transaction. So in that temporary workspace, you are going to update this particular value. You are not going to write it in the database. Once that has been done, that means execution is all the steps of that transaction have been executed. The next you go to the validation phase. In the validation phase, you are going to check for any kind of violation, whether the transaction has violated any particular thing. If there is a violation, then during the write phase, you have to discard the changes that you have made, abort the transaction and restart the transaction. But if this validation phase is successful, then you are going to commit that transaction and then you are going to write this final updated value into the database. So in case of concurrency control, all the checks are done all at once. Hence, your execution of your overhead time will be reduced, which will improve your transaction execution. Any doubts, anyone? We are using it in database. All DBMS uses concurrency control. How do you implement concurrency control? It depends. That's all. Whether you are using locking technique, whether you use this timestamp, that is always a variation. But all DBMS, commercial DBMS packages will have to use concurrency control. Otherwise, you will not be able to execute the transactions simultaneously. Because suppose you take this IRCTC website, railway reservation website. As I told you in the previous classes, both you and me may be trying to book at the same time. You may also book from the same place to same source to same destination. I may also book from same source to same destination, same date. Everything is same, but still we both are able to do without any hassles. Why? That is because of this concurrency control technique which is implemented. Every database will have to implement this concurrency control technique.
Thank you, ma'am.
Yeah. Okay. So next we move on to that is about concurrency in case of using timestamp or optimistic concurrency, optimistic or validation concurrency control. Next we go on to we go to a new next important concept, which is database recovery techniques. Now, under this, we are going to learn about recovery concepts. We are going to learn what is or how is recovery in multi-database systems. And then we will also be learning database backup and recovery from failures. These are the 3 concepts that we'll be learning under database recovery techniques. Okay. So first, we'll start with recovery concepts. This is the last part of your last concept of your syllabus, but again we have all these concepts to be addressed. Recovery concepts. Now, under this recovery concepts, again, you have so many things to be learned. First, we'll be learning recovery outline. And categorization of recovery algorithms. Okay. This is the first thing that we'll be learning. Recovery outline. That means a general introduction to what exactly is recovery. And we'll also see what are the different categories of recovery algorithms are there, right? Now, let us try to understand what do we mean by recovery. Any answers? Any answers? What do we mean by recovery in a
Ma'am,
database?
it's a backup.
Yes, very good. Anyone else?
Recovering any data that might be corrupted or something like that.
Okay. Right. Now, when we talk about recovery, recovery will always come when there is going to be some kind of transaction failures. If there is a transaction failure, then you have to recover. Means what? The database has to be restored back. You have to restore back the database to the most consistent state. Just before the time of failure, what was your state of your database? You have to bring your database back to that state. You have to restore your database to the state which it was in before the time of the failure. Suppose I do a debit before I credit, the database as transaction has failed. So before it failed, what was the status? You had debited, no? You had to restore that. And then before you did this particular debit credit operation, both are part of your transaction. If you have not done one, you should not do the other also. So you will have to restore it, means you have to undo your debit. That is what we mean by saying restoring the database to a consistent state. So I'll have to undo the debit there because otherwise it will remain inconsistent. Somewhere a debit has been done, but there is no credit at all. Then that means it is inconsistency. So what is a consistent state then? I will undo the debit also. So then it becomes consistent back to the state before the failure happened. So you bring back or you restore the system back to the state just before the time of failure. Before the failure, what was your state of the system? You will have to bring back the system, or the DBMS has to bring back the system or restore the system to that point. That is what you call it as recovery. So what to do this? What you the system should simply the system cannot do this particular activity. It is not so easy as we say. So system it should keep information about the changes that were applied. So if I have done a debit, I should store that information somewhere that a debit has been done. Only if you are storing that information, you can go back and trace back and undo it. Correct? Where do we keep? Where does the system keep this information? We were talking about system log a couple of days back. So system log is a place where every activity that is done or every transaction or every step of the transaction that is done will get recorded in this log. So the DBMS will store everything in this particular log. So if there is going to be a failure, the log will still have that particular information. So you can go back and trace back and undo that particular operation. There are certain strategy for recovery. Okay. Now, all the recovery need not be the same way to undo. Okay, sometimes we may not be able to undo at all, right? So in that case, how we can go about it? Now, if there is a too much of a damage to the database due to some catastrophe or due to some catastrophic failure, let us say disk crash, something like that happen, then the recovery method, it should restore the previous copy of the database that was backed up. So you are going to keep an archive of or archival storage of all the information, and you have to reconstruct one more state by redoing some operations from the system log. So that means up to the time of the failure, what all happened, you will have to probably redo all that, because a disk has crashed. You are not able to undo and keep that system in a consistent state. So you will go back to your system log, look into the backup that you have already taken, reapply all these operations, whatever transactions you have already committed, all that is lost now because your disk has crashed. So you will have to reapply whatever committed transactions are there. You will have to reapply them, redo these transactions, and then bring the system to a consistent state. That is one of the strategy of recovery. When this will happen, when you have an extensive damage which is done to the database, most wide portion of your database is all damaged completely because of some catastrophic failure. Catastrophic failure could be a disk crash, can also be a catastrophic failure where you have lost most of the things. Then you will still have to bring the system, because you cannot say, okay, disk has crashed and I can't do anything. That is not right. You still have to, the recovery method has to restore the database. How do you restore it? You have a backup, you have an archive. There is a system log where everything gets recorded or gets stored. So if you have committed certain transactions till the time of the failure, all those committed transactions are also recorded in the system log. So those committed transactions, you may have to once again do it. You may have to reapply those particular transactions. That is one strategy for recovery. Second is, if the database is not physically damaged. The first case was where I said it is a catastrophic failure, disk crash, means that let us say there is some physical damage there. Suppose if the database is not physically damaged, but it has become inconsistent. There is a lot of inconsistencies because of some failure, again, non-catastrophic failure, let us say. We have already discussed what are the different types of failures in one of the previous classes. Okay, then you can, in this case, what you can do, you can reverse any changes that cause the inconsistency. In this case, we can try to undo the operations. Some operations you may have to redo, some operations you may have to undo. Because you are physically, nothing is damaged here. But it has led to the failure has led to lot of inconsistencies. It is not consistent. So somewhere debit has happened, no credit has happened. That is nothing but an inconsistency. You can always undo the debit. But everything is, in the first case, everything is lost. So you cannot undo anything. There is nothing at all. So you will have to redo. These are the two different important strategies when we talk about recovery. There may be a case where you have major damage done because of some major failure, major natural disaster. Something has happened and you have lost everything. In that case, you will have to redo all your committed transactions. There may be a case wherein you don't have any kind of physical damage done, but it is a non-catastrophic failure. In that case, a non-catastrophic failure will always lead to some kind of inconsistencies. Inconsistencies are there, and that's why you can always undo. Here also, we don't say it is completely undo. Rather, you could redo some operations, plus you can undo some operation to bring or restore the database to a consistent state. All the entries that you have kept in your log will be referred to when you want to do a recovery. Otherwise, it becomes difficult. Right? So we can distinguish two main techniques for recovery. Okay, two main techniques for recovery. That is, we are talking for the non-catastrophic failure. That means there is no major physical damage. So what are the two main techniques? Two main techniques for recovery from the non-catastrophic transaction failures or non-catastrophic failures. One is called as the deferred update. The other one is called as immediate update. Okay, these are two main techniques. We can distinguish between these two techniques for recovery. Okay, from the non-catastrophic failures. One is deferred update, immediate update. Deferred update means what? Deferring means what? You try to postpone. English meaning of deferring is postpone, right? So deferred update, you are not going to physically update the database until your transaction has committed. Only after it reaches if the transaction has reached the commit point, only then you are going to update your database. Till then you will not do it. Till then you are going to record it in your local workspace or that local transaction workspace. What I said, you are going to update all the data items in the local workspace until the transaction reaches the commit point. Okay, during the commit, the updates are first recorded in the log and then you are going to write it in the database. When you reach when the transaction reaches the commit point, you are going to first make all the entries in the log, then you make a permanent entry in the database. Okay, so if the transaction fails, let us say, if the transaction fails before reaching the commit point, it has failed. It has not committed. Before committing only, it has failed. So what will happen? It would not have made any changes in the database because you have not given the commit. None of the changes are permanent there. It would not have made any changes in the database. So that's the reason undo is not needed. You don't have to undo anything because nothing has changed in the database, because before committing only the transaction has failed. You may have to redo. You may have to redo the committed transactions. Whatever has got committed already, those transactions you may have to repeat. You may have to do it again. That is what is called as deferred update. Deferred update is also called no undo / redo algorithm. Okay, no undo or redo, because we are not undoing anything. So what did I say? There are two techniques. One is deferred update. The other one is immediate update. In the deferred update, what will happen? So in the deferred update, the transaction is not going to update the database permanently until it reaches the commit point. When it will reach the commit point? Only when it is successfully finished the transaction, right? When the transaction has successfully completed its execution, it will reach the commit point. Once you give a commit, that means what? All the changes that you have made will become permanent, right? So until you come to the transaction comes to the commit point, no updates will be done in the database. So then where is it going to do all the updates? Suppose a transaction does the write operation. Where does it do that? It does it in the local workspace. All the changes will be done in the local workspace. Once it reaches the commit point, it will make an entry of everything in the log and then permanently write it into the database. Right? Now, suppose a transaction has failed. Suppose a transaction has failed even before it reaches the commit. So in that case, what will happen? Nothing has been recorded permanently in your database at all, because it has failed before giving the commit instruction or the commit transaction. Commit command. It has not done, so it has not done any changes. So you don't have to undo anything. You don't have to undo anything because database has not changed at all. You may have to redo certain operations. You may have to redo certain operations. Certain committed transactions you may have to redo to bring the database back to certain consistent state. That is why this deferred update is also called no undo or redo algorithm. no undo or redo algorithm. Okay, any doubts?
No,
Next technique
ma'am,
is,
can I
yeah,
ask
tell me.
one
Yeah,
doubt, ma'am?
tell.
Ma'am,
Yeah, tell me.
ಮ್ಯಾಮ್ ಇದು ಸಿಸ್ಟಮ್ ಎಲ್ಲಾದ್ರೂ ಹಾಳಾದ್ರೆ ಮ್ಯಾಮ್ ಸಿಸ್ಟಮ್ ಎಲ್ಲಾದ್ರೂ ಹಾಳಾದ್ರೆ ಮ್ಯಾಮ್ ಇದು VMware ಅಲ್ಲಿ ಮ್ಯಾಮ್ ಇದು ಬರೀತಿರುತ್ತಲ್ವಾ ಅದು ಹಾಗೆ ಇರುತ್ತೆ ಮ್ಯಾಮ್, ಇದು ರಿಕವರ್ ಮಾಡೋಕ್ಕಾಗಲ್ವಾ?
ಯಾವ್ದ್ರಲ್ಲಿ? ಐ ಡಿಡ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಯುವರ್ ಕ್ವೆಶನ್ ಓನ್ಲಿ. ಅರ್ಥ ಆಗ್ತಿಲ್ಲ ನೀವು ಹೇಳೋದು. Come one-on-one later, I will discuss. So the next technique is immediate update technique. Here in this case, what will happen? The database may be updated
the
by some
VMware, ma'am.
operations of a transaction. You come later, no? You come ask me later.
ಮ್ಯಾಮ್ ಇದು ಸಿಸ್ಟಮ್ ಏನಾದ್ರು ಮ್ಯಾಮ್ ಇಶ್ಯೂಸ್ ಆದ್ರೆ ಮ್ಯಾಮ್
Akruti, you talk to me later. I will listen to you. Yeah. So in case of immediate update, what will happen? The database immediate update, in this case, some of the operations may get immediately updated to the database. That's why it is called as immediate. The first case we had called it as deferred update because we are doing the update only after the commit. Here immediate update means the database is updated. Some of the operations are updated even before the commit point, even before the transaction commits. Some of the operations are updated in the database. So that means you are trying to record it in the log and then make the changes permanent in the database before the transaction has committed. So before the transaction has committed means the transaction is still under execution. Suppose if it fails, what will you do? If the transaction fails, some changes you have already recorded or already updated, some you have not done. So, but then before reaching the commit point, the transaction has failed. Then, so what can be done? The transaction in that case has to be rolled back. You have to roll back the transaction because you have already done some changes already. So you have to undo this. Immediate update is also called as undo or no redo. You cannot redo anything. You have to undo because this has brought some changes. Both undo and redo may be required sometimes during the recovery, but this is called as undo or redo. Undo or redo. No, sorry. Okay, I'm sorry. It has made some changes. Okay. Made some changes in the database already. So if it fails, then you have to undo. You also have to sometimes redo this operation. So this algorithm is also called undo or redo, wherein it requires both the operations to be done. Variation of it is wherein you do only undo is required. That is called as undo or no redo. So we have three different types of algorithm. The previous one, what I explained, no undo or redo. One more is undo and redo. Here is undo and no redo. See here in this case, undo and redo, what will happen? I said immediate update means the database, some operations of the transaction will be updated to the database before it reaches the commit point. That means you are trying to register them in the log and then make the corresponding changes in the database also. After you have made the database changes, let us say that the transaction is still not committed. So let us say the transaction fails. After you have made some changes in the database, but before reaching the commit point, it has failed. What will happen? You have to undo all the operations that has been done so far. So that means you are trying to roll back the transaction. So in this case of immediate update, both undo and redo also may be required during the recovery. Some steps you may have to redo once again. And whatever changes you have done until that failure point, you have to undo all of them. That is why you call it as undo or redo. Suppose you have, I said some operations only you have updated, not all the operations. Suppose you have updated, all the operations are updated in the database, let us say, before the commit. Before the commit, all the operations you have, it is all updated in the database, assuming that, before you commit. And then the transaction fails without even committing. In that case, you have to undo all the operations. There is no need of any redo. That is why a variation of that, you call it as undo or no redo. Right? So these are the three algorithms which we learn under this recovery technique. So the recovery techniques, we can classify them into deferred, what do you say? Deferred update and immediate update. Deferred update, you are not making any changes in the database until the transaction comes to the commit point. During the commit point, after it commits, you are going to permanently make the changes in the database. Till then, you have made all the changes only in the temporary workspace of that particular transaction. Okay, so before committing, if the transaction fails, you don't have to undo anything at all, because there is no change in the database. That's what we call it as no undo or redo algorithm. No undo. Some operations may have to be redone, but there is nothing to be undone because there is no changes which is permanently recorded into your database. The second case we saw is immediate update. So immediate update here, there are two cases again. First case where some of the operations are permanently recorded before the commit point. The second case where all the operations are getting recorded in the database before the commit point. In both these cases, if the transaction fails before the commit, so in the first case, you have to undo and redo also. Second case, you have to undo, but there is no need of redo because all the operations you have finished already. The transaction is finished. After finishing everything, it has failed, even but it has not committed. So you have to undo the transaction. Any doubts at this point?
No, ma'am.
Next, we see what is caching of disk blocks. I think this is very similar to what you have already studied in OS. So recovery process is always linked with your OS concepts. You cannot say recovery is different, OS functions are different. It is always, both are intertwined. Okay, both are linked always. The buffering and caching of disk pages in main memory. Suppose you want to execute something, then what will happen now? From the OS, what it will do, from the disk, it is going to bring that, let us say you are using the concept of pages. From the disk, it will bring that page into the main memory. Right? And there is also some, buffers. You can call it as cache memory. I don't know. You would have studied it in operating system. Are you all aware of that?
Yes, ma'am.
Yeah. So whatever updates are made to that particular page will also, a copy of it will be kept in that cache memory also. So cache memory will always have the copy of the recent execution that has happened. And cache memory is always less in size compared to your main memory or compared to your even your disk space. So if this cache memory becomes full, then you will have to roll out one of the page to your disk and bring in the new page, which we call it as swapping. And to do this, how do you replace? Which page has to be replaced? All this, we have this kind of page replacement algorithms. I hope all of you would have studied that. Have you all studied?
Yes, ma'am.
Yes, ma'am.
Yes,
Yeah.
ma'am.
Can you name some of the page replacement algorithms?
Five.
FIFO, LIFO.
Yeah. FIFO, that is first in, first out. You can use a what to say, LRU, least recently used.
Yes, ma'am. Please.
Yeah.
And optimal page replacement algorithm.
Correct. All these page replacement algorithms will come into function here. So that's how you try to make first you make a temporary updation in your cache memory when the page is in the memory. Once it is there into your disk flow, you try to write the whole thing, update in the disk as well. So in that case, you also make use of something called as the dirty bit or the modified bit. That means the system will keep track of which of these have to be really updated every time a particular page is updated. You don't have to go and update it into the disk. So you keep a mark whenever that page has to be replaced, only that time you are going to update it. So these are all OS concepts. Well, I think many of you all know that. Let's start with it. Answer your attendance. Anaga,
Yes, ma'am.
Akrut, Abhilash, sorry, Akhil, Akrut,
Yes, ma'am.
Anusha,
Yes, ma'am.
Arifullah,
Yes, ma'am.
Benaka,
Present, ma'am.
Banu,
Yes, ma'am.
Bhargav,
Yes, ma'am.
Rahmatullah, Chaitra,
Present, ma'am.
Chandana,
Present, ma'am.
Charan, Darshan. I didn't call you only, you were telling before that. Diksha,
Yes, ma'am.
Rachayani,
Present, ma'am.
Kishan,
Present, ma'am.
Harshit,
Present, ma'am.
Nema,
Present, ma'am.
Huma,
Present, ma'am.
Jay,
Present, ma'am.
Divya.
Ma'am, she's attending placements, ma'am.
What time?
At 1 o'clock, ma'am. She just left now.
Kaushik,
Present, ma'am.
Lakshmi, Lavanya,
Ma'am, she is attending placement, ma'am.
Manish, Manoj,
Yes, ma'am.
Mohit, Naval,
Yes, ma'am.
Navya,
Present, ma'am.
Nikhil, Parindra, Pavan, Pooja, Purnima,
Present, ma'am.
Present, ma'am.
Raman,
Present, ma'am.
Ashmi, Sai Kumar,
Present, ma'am.
Present, ma'am.
Samir, Santosh, Shadav, Sharan, Shashank,
Present, ma'am.
Peter, Shivani, Soumya,
Present, ma'am.
Spurti, Vishnu,
Present, ma'am.
Present, ma'am.
Surendini, Sushma, Sushma is not there. Okay. Sushmita,
Present, ma'am.
Smita, you,
Present, ma'am.
Tirtha, Tripti,
Present, ma'am.
Varshavina.
Present.
Present, ma'am.
Ma'am, Lakshmi is present. She has put in chat box.
Why she is not able to speak, is it?
Ma'am, I don't know, ma'am. Her mic is not working, ma'am.
Then how do you all manage placements?
I don't know, ma'am.
Then that time mic will work properly.
Yeah, ma'am. I'll speak with her, ma'am.
Only during this class, all network issue, mic issue, all power issue, every issue will come. Huh? Otherwise, there is no issue at all.
Ma'am, I'll tell her, ma'am.
Thank you.